From the air, Palm Jumeirah looks like a completely finished masterpiece, a permanent addition to the map of the world. But underneath the luxury resorts and private villas, a very different physical reality is playing out. Dubai did not just build one of the most famous artificial coastlines on Earth. Recently, it had to send heavy marine equipment back to put approximately 1.5 million cubic meters of sand back onto those very same beaches. How does a city engineer an entire island from scratch, but struggle to keep the sand exactly where it was originally placed? When you look at Palm Jumeirah today, the visual illusion is seamless. The inner fronds are packed with thousands of permanent homes and manicured gardens. The outer crescent is lined with massive hotel structures that look entirely immovable. If you were standing on this beach, watching swimmers and sitting on a shaded sun lounger, would you ever imagine that engineers still had to work on keeping this sand right here? Human perception tells us that once a massive construction project is officially open to the public, it is finished. We naturally assume that the hardest part of the engineering challenge was the initial dredging, the careful placement of the rock breakwaters, and the shaping of the island footprint. And for the developers, the primary construction phase did eventually come to an end. But the ocean does not operate on a human construction schedule. Coastal movement does not simply clock out just because the real estate has been sold. The water that surrounds these fronds never stops interacting with the land it touches. The realization slowly sets in that the physical boundary between land and sea is never truly fixed. And so, years after Palm Jumeirah was declared a global triumph of modern engineering, the heavy marine equipment had to come back. In September 2022, Nakheel, the developer behind Palm Jumeirah, initiated a massive beach enhancement program. By the end of 2023, the sheer scope of that coastal engineering work became entirely clear. This was not a minor aesthetic touch-up or a simple landscaping job for a single hotel property. The enhancement project covered approximately 55 kilometers of beachfront. Contractors had to physically adjust the slope and the width of the shoreline, repairing extensive sections that had been affected by natural erosion over time. To achieve this restored profile, they added approximately 1.5 million cubic meters of specialized marine sand. That is an absolutely immense volume of material. Imagine trying to fill hundreds of Olympic swimming pools to the brim with pure, wet sand, just to carefully reshape the edges of an island that was already built. This is the complex reality of managing a heavily engineered waterfront. Dubai proved that it can easily put millions of cubic meters of sand into the sea to create new real estate. But it simply cannot order that sand to remain permanently frozen in place. The scale of this specific enhancement program proves that artificial coastlines require active, ongoing intervention to maintain their original design parameters. But this massive operation immediately raises a very obvious question. If marine engineers had already placed millions of tons of material here to build the palm in the first place, where was the original beach actually going? To understand exactly where the sand goes, you have to change how you fundamentally look at a shoreline. We tend to think of a beach as a permanent, solid floor. In reality, it is much more like a physical conveyor belt moving extremely slowly along the edge of the land. A beach is a highly dynamic environmental system. Every single breaking wave picks up thousands of microscopic grains of sand and shifts them slightly down the coast. Coastal currents continuously drag this suspended sediment along the shoreline. The wind constantly rearranges the dry surface profile, while seasonal storms can violently reshape the entire gradient of the shore. Even on a perfectly calm afternoon, the beach is in constant motion. Under natural conditions, sand is constantly being taken away from one spot and deposited in another. But Dubai did not merely build its city beside that moving conveyor belt. It placed enormous, rigid structures directly into that active coastal system. Whenever you introduce a massive physical obstacle into the open ocean, you completely alter the local hydrodynamics. This rule of physics applies to anything from a simple concrete harbor breakwater to an entire artificial archipelago. Large coastal structures physically interrupt the natural flow of water. They block incoming waves from hitting the shore at their original angles. They change the direction and the velocity of local currents. They cast massive wave shadows and create new hydrodynamic zones where the water moves either much faster or much slower than it did before. This does not mean that artificial islands automatically cause every single erosion problem along the coast of Dubai. But it does mean that engineers can no longer assume the surrounding sand will behave exactly as it did in the past. When the physical energy of the water is redirected by a new island, the sediment transport cycle changes right along with it. Sand might begin accumulating heavily in one quiet corner of a frond, while simultaneously being stripped away from a stretch of valuable resort beach just a few hundred meters down the shore. Engineers try to manage this restless movement by building coastal defense structures like groynes. These are the long, narrow structures of rock or concrete you often see extending out from the dry sand into the water, specifically designed to trap moving sediment and hold the beach in place. But if the sand naturally wants to keep moving, can Dubai ever simply stop it completely? The short answer is not completely. You cannot permanently freeze the physical energy of the ocean, which is why one of the primary answers is not simply protecting the existing sand with barriers. It is actively putting new sand back. To rebuild a beach on this scale, coastal engineers essentially have to repeat the massive steps that created the island in the first place. First, they must identify a reliable source of suitable marine sand that matches the exact physical requirements of the existing shoreline. Massive dredging vessels are deployed into the open ocean offshore, lowering heavy extraction equipment to collect this material directly from the sea floor. The dredged sand is then transported back to the artificial coastline and pumped onto the eroded areas in a thick, heavy slurry of sand and seawater. But simply pumping the material onto the coast is only the beginning of the precision operation. Heavy excavators and specialized bulldozers must move continuously back and forth along the shoreline, physically spreading the wet sand. They have to carefully reshape the slope and establish the precise underwater gradient that the original hydrodynamic design requires to safely dissipate incoming wave energy. If you were to stand on the shore and watch this heavy machinery operating, it looks exactly like a brand new, heavy industrial construction site. But this is not new construction at all. This is purely maintenance. It is the heavy industrial cost of keeping an artificial coastline looking effortless, natural, and pristine for the people living on it. The operation requires specialized marine contractors, heavy machinery, and continuous financial investment years after the luxury properties were originally sold. Which logically leads to the most practical question of all. What happens if Dubai simply stops doing it? If the heavy dredgers never returned, the island would not suddenly sink into the sea. Palm Jumeirah is absolutely not going to disappear completely tomorrow. The structural core of the island is heavily protected by massive rock revetments on its outer edge. But the sandy beaches on the inner fronds are a very different physical story. Without active, ongoing sand nourishment, the natural movement of the ocean currents would gradually strip the placed material away. The immediate physical consequence is that the overall beach width would begin to noticeably shrink. Valuable recreational space for luxury resorts and private residents would simply wash down the coast. More importantly, the critical sandy buffer between the open water and the fixed physical development would steadily decrease. The physical distance protecting expensive residential villas, retaining walls, and hotel swimming pools from the incoming waves would narrow year after year. As that protective physical buffer slowly deteriorates, the entire premium waterfront tourism experience that Dubai actively sells would degrade right along with it. The real danger here is not an overnight structural collapse of the entire island system. The fundamental problem is that an engineered coastline cannot simply be declared finished and left alone to face the ocean. At this point, a very obvious question arises for anyone looking at the sheer cost of dredging. If sand is so incredibly difficult to keep in place, why not just replace the moving beach with solid concrete? A vertical seawall would certainly stop the shoreline from constantly shifting. It would successfully lock the physical boundary between land and water permanently in place, without requiring millions of cubic meters of new sand. But a concrete wall completely changes the economic equation of the entire coastal development. Dubai does not only need raw physical protection from the water. Its coastal mega-developments are specifically designed and built to sell sand. They sell direct beach access, uninterrupted ocean views, waterfront recreation, and a premium resort lifestyle. You cannot successfully sell a luxury tropical resort experience if paying guests have to look at a harsh concrete barrier instead of walking directly into the water. A wall can successfully protect the land sitting behind it, but a wall cannot perform the recreational function of a beach. Therefore, engineers are forced to use a complex combination of site-specific coastal engineering methods. They carefully place groynes, rock revetments, and underwater breakwaters to slow the wave energy down. And they combine that hardware with expensive, ongoing sand nourishment to keep the shoreline usable and visually attractive. Because of this complex physical reality, Dubai has to watch the water constantly. Dubai Municipality operates highly specialized hydrographic and oceanographic monitoring infrastructure. This complex system includes a network of tide and meteorological stations situated along the coast and deep into Dubai Creek. They also maintain offshore buoys that continuously measure oceanographic conditions, capturing wave height and direction before that energy even reaches the shore. From the quiet balcony of a luxury hotel, the sweeping beach below looks completely natural, permanent, and entirely effortless. But directly behind that pristine view is a relentless, invisible cycle of physical measurement, monitoring, and data collection. Specialized survey vessels regularly map the seafloor to track exactly how the sediment is moving over time. They are constantly watching to see exactly where the ocean conveyor belt is taking the valuable sand. Once a city creates enough engineered waterfront, the beach fundamentally begins behaving less like beautiful scenery. It begins behaving much more like highly demanding municipal infrastructure. It requires the exact same level of technical attention, tracking, and ongoing physical maintenance as a highway network. But is Palm Jumeirah merely an isolated, unusual case in this desert city? The immense pressure of maintaining an artificial shoreline actually extends far beyond the footprint of the palm. In June 2026, Dubai Municipality detailed major engineering works at another highly visible coastal location. This was Jumeirah Beach 1. The municipality reported that the engineering works included raising the overall beach level and replenishing the area with approximately 250,000 cubic meters of clean sand. This massive sand placement was carried out as part of broader climate resilience measures, carefully based on detailed technical and environmental studies. This is a completely different geographic location with a different historical context than Palm Jumeirah. But its storytelling purpose reveals a very important pattern. Significant sand placement and proactive coastal adaptation are absolutely not confined to a single offshore megaproject. They are rapidly becoming standard operational requirements along the entire developed edge of the city. Engineers are continuously working to hold the physical line against an ocean that never stops moving its boundaries. At what point does replacing and reshaping hundreds of thousands of cubic meters of sand stop looking like a one-time construction job? When does it fundamentally start looking like an ongoing, permanent city service that must be funded and executed forever? Maintaining this shifting boundary requires immense engineering effort, specialized data collection, and continuous financial investment. And despite this massive maintenance burden, Dubai is absolutely not reducing how much beachfront it has to manage. If you look at the sheer scale of the physical maintenance required to keep these existing shorelines intact, a logical assumption might begin to emerge. You might naturally expect that developers would eventually move away from this high-maintenance model. Perhaps the long-term response to relentless coastal movement would be to simply create less engineered waterfront. Instead, Dubai is currently doing the exact opposite. The city is actively investing in an even larger, more complex marine boundary. The most prominent example of this dramatic expansion is the ongoing development of Palm Jebel Ali. Current official project information outlines an absolutely massive new physical footprint directly in the water. The development spans 7 distinct islands. It features 16 separate fronds extending far out into the Gulf. Most importantly, the master plan is designed with more than 90 kilometers of new beachfront. This represents an enormous, unprecedented addition to the artificial coastline of the city. Every new kilometer of sand placed into the ocean does not automatically inherit the exact same erosion problem as older projects like Palm Jumeirah. Coastal hydrodynamics vary wildly depending on the specific geographic location, the orientation of the islands, and the modern protective structures built around them. But every single engineered beach does undeniably create another permanent boundary between land and sea, and the physical behavior of that newly placed boundary will have to be closely measured, understood, and actively managed over time. When you realize the sheer volume of sand and infrastructure being added to the map, the perspective on Dubai's engineering fundamentally shifts. The city is actively multiplying its coastal responsibilities. This forces us to ask a much larger question. Is Dubai's greatest coastal engineering achievement really how much new land it can successfully dredge and shape from the seafloor? Or will its true achievement be how successfully it can manage and maintain those coastlines for decades after the initial construction ends? The challenge of managing these coastlines for decades is intensified because the ocean they are building in is not a static environment. The physical conditions of the water do not permanently freeze on the day a megaproject officially opens to the public. Long-lived marine infrastructure has to survive in environmental conditions that may not have been present during the original design phase. A peer-reviewed engineering study published in 2023 highlights this reality perfectly. Researchers critically examined potential engineering upgrades to the massive outer rock revetment that protects Palm Jumeirah. The primary focus of the study was not about fixing an imminent structural failure. Instead, it evaluated how to practically extend the design life of the protective breakwater by approximately another 50 years. Crucially, this engineering analysis had to carefully consider various sea level rise scenarios. This type of study does not mean that the island is currently failing. It simply demonstrates that artificial coastlines are continuously subject to long-term environmental pressure. If the baseline water level shifts upwards, or if the intensity of seasonal storms increases over time, the original hydrodynamic assumptions change right along with them. The ocean simply does not preserve the design assumptions of the year a project opened. Building the coastline was fundamentally a massive, one-time engineering project. Keeping it functional and safe against a changing climate becomes a permanent management problem. When we closely examine the entire coastal system of Dubai today, the popular narrative we have been sold starts to look fundamentally incomplete. For years, the attention of the world was entirely focused on the massive physical scale of dredging an archipelago from the sea floor. We watched the satellite imagery change as Palm Jumeirah took its iconic shape. We saw the heavy dredgers pumping millions of tons of material into empty water to create something from nothing. But that was only the very first phase of the story. The most complex part of this engineering saga is not simply constructing impossible objects. The truly hidden story only begins after the heavy construction crews leave and the hotel guests arrive. It is the story of heavy groynes, strategically placed to catch drifting sediment before it washes away. It is the reality of offshore monitoring buoys quietly recording wave data. It is the site of Jumeirah Beach 1 requiring hundreds of thousands of cubic meters of fresh sand to maintain its climate resilience. And it is the massive future commitment of adding more than 90 kilometers of new shoreline at Palm Jebel Ali. The fundamental question we ask about these mega projects has to evolve. We have spent 2 decades simply asking how Dubai managed to build this. The much more interesting question is how Dubai manages to keep this. So we return to the iconic view from above. From the air, Palm Jumeirah looks exactly as it was originally intended. A completed, permanent addition to the map. The island absolutely still exists, its structural core is protected, and its luxury beaches are still functioning beautifully for thousands of daily visitors. The presence of a massive beach nourishment program is absolutely not evidence of a spectacular engineering failure. It is simply the heavy operational tax of maintaining an artificial shoreline in a dynamic world. But down on the ground, where the water actually meets the sand, the coastline reveals something entirely different. The sand constantly moves. Oceanographic engineers constantly measure it, and eventually, some of those engineered beaches require heavy restoration to survive. Despite this massive ongoing effort, Dubai continues to press forward, creating even more engineered waterfront. Therefore, we have to permanently change how we view the physical edge of this city. The coastline of Dubai is not simply a static, finished object that developers built and walked away from. It is something the city inherited an endless, incredibly complex responsibility for. Every meter of artificial beach is a living, shifting system that demands continuous observation, adaptation, and heavy machinery to remain exactly where it is. Dubai didn't defeat the sea. It entered a maintenance contract with it. This video is for educational and documentary purposes only. The information presented regarding coastal engineering, municipal projects, and environmental studies is based on publicly available data, technical reports, and official statements at the time of production. It does not constitute professional engineering, environmental, or financial advice. How much continuous maintenance do you think is justified to keep an artificial coastline functional? Share your thoughts in the comments below. If you found this investigation insightful, please subscribe to the channel for more deep dives into the hidden systems that keep the modern world running.